All right, so we are going to be beginning a new section in Chapter 2, and we are going to be taking notes on a blank sheet of paper and attaching them into your notable. So this is something that we might do from time to time. Um, so what I want you to be titling these notes, make sure you have your pencil ready and your blank piece of paper. Title your notes, solving one-step equations, and we're using adding and subtracting. So we need to know that we are only going to be using adding and subtracting today, no multiplying or dividing. And I'm going to show you how to do that. So what I'm going to do for these is highlight all the things that you need to be writing down. So again, we're titling our page, solving one-step equations using adding and subtracting. You should either be writing down everything that I'm highlighting or writing down whatever I'm writing, if that makes sense. So, for example, I'm going to be writing something down here. I want you to be writing it along with me. If it's typed and I highlight it, go ahead and write that too. So, first thing we need to know when adding and subtracting one-step equations, solving them, is whatever you do to one side, whatever you do to one side, what? You have to do to the other. You have to do to the other. So, just to clarify, since I wrote this down, this should be written in your notes. It's a rule that you are going to use for a long, long, long time. This should also be written as your title. All right, so whatever you do to one side, you have to do to the other. What do I mean by that? We want to keep our equation balanced. So another note, we want to keep our equation balanced. Now, what does balanced mean? It means the same on both sides. If we have 3 over here on one side of our equation, we want 3 over on this side of our equation, but there's a number of ways we can get to 3. Over here on this side, we can have 2 plus 1. What else could we have? We could have 4 minus 1. We could have 5 minus 2. Over here, if we want to keep it 3, we could have, 12 minus 9, things like that. So we want to keep our equation balanced. We want to keep it equal on both sides. I'm going to show you a little representation of this. So this is a little web page that I found. It's at mathisfun.com. It is balance when adding and subtracting. So here we have a very old balance that they used to use to see how much things weighed. And notice that it's level. This means that both sides of our equation, x plus 2, and over here 7, that means it's level. They're equal. Now, what they want us to do is try to get x equals on this side. So we want to try and get this side of our equation or this side of our balance to just have one x on it. So what do? We want to minus 1. See how this has a minus 1? We want to minus 1 from this side, and that means it's taking this 1 away from it. Now notice when I press minus 1, it takes it away from this side and this side. Notice when I press minus 1 again, it takes it away from this side and this side. So what does our x equal? 5. So let me add those two ones back up. You might just be able to say to yourself, okay, what is x plus 2 equals 5? Well, or equals 7. We already know x equals 5. But believe me, it's going to get a lot more difficult, and we need to make sure we know to keep whatever we do to this side, we have to do to this side. So we minus 1 from both sides. Our stack right here gets shorter. Our stack right here gets shorter. We now have x plus 1 equals 6. Again, we get x equals 5. And notice there's 5 ones over here and 1 x over here. So this x is all by itself. It's isolated. That's a word we're going to talk about. Your x is isolated, so you know you have your answer, x equals 5. So let's go prove this mathematically. All right, so our first example here, we have x plus 6 equals positive 2. X plus 6 equals positive 2. What I want to do first is write it out as a balance. So if we have our old time balance here, remember we want to keep it flat. You have on this side, we're going to do the positives in blue and the negatives in red. Over here I have positives in blue, negative in red. I have a x and a positive 6, and I'm just going to represent this by drawing 6 lines. 1, 2, 3, 4, 5, 6. On this side, I only have 2 lines. So, if I want this x to be isolated, get it all by itself, I need to start taking off these ones over here and putting them over here. Well, how do I do that? If I take off this top one here, then I take off this top one here. Now if I take off this top one here, I take off this one over here. But notice how now we're unbalanced. We're balanced. We have 0 over here, but we still don't have our x isolated over here. So now when I take one off over here, I'm going to add it in red right over here. So I'll do it again. I'm going to take one off in red over here, and I'm going to add it in red over here. I'm going to take one off in blue over here, and I'm going to add it in red. Remember, red is negatives. And one more time, last and final time, I'm going to take one more blue off, and I'm going to add it in red over here. So now you might be thinking, okay, what is all of this for? And I'm going to tell you right now. Let's summarize it. So we have our x isolated. It's all alone on this side. And how many negatives do we have over here? We have negative 4. So on this side of our equal sign, we have our positive x. Remember, we want x to be positive, and we want it to equal 1, 2, 3, 4. Well, remember, red is negative, so this is going to equal negative 4. So now let's check it out. How do we check it out? We plug in negative 4 for x, and we see if it works. Does negative 4 plus 6 equal 2? Does it? We'll put a question mark. Yes, it does. Negative 4 plus 6 does equal 2, because 2 equals 2. Yay, everything checks out. Now let's represent the same thing without the scale. Let's do it mathematically. You'll find that this way is a lot faster to do. So we still have the same equation, x plus 6 equals 2. What we want to do is we want to subtract 6 from this side. Well, remember, whatever we do to this side, we have to do to this side. So we're going to subtract 6 from this side. Now we have a big math problem. Well, x plus 0 equals x. Plus 6 minus 6 equals 0. So we basically just cancel these out. We still have our equal sign. And we have 2 minus 6. That equals negative 4. So x in this case equals negative 4. Again, to check that out, we say, all right, does negative 4 plus 6 equal positive 2? Does it? Yes, because 2 equals 2. All right, let's try another example. All right, let's try this example. Y plus 12 equals 4. Again, when I'm writing things down like this, you should also be writing them down. Our first step for this is we're going to subtract 12 from both sides. So again, big problem, y plus 0, nothing here, is y. Positive 12 and negative 12 equals 0. Minus 12 is going to give us negative 8. So y equals negative 8. And we can just put a big old box around that. Now remember how we check that out. Does negative 8 plus 12 equal 4? And yes, it does. Negative 8 plus 12 equals 4, and 4 equals 4, and we are happy because it all checks out. All right, this one's a little bit of a different, plus m equals 6. Now remember this variable I. So in the past two problems, we've been subtracting 12. We were subtracting 6 because our number was positive. Well, now in this example, our number is a negative number. So instead of subtracting 7 from both sides, what would we do? Well, we would add 7 to both sides. We're trying to get it 0 because we want this m all by itself. So when we add 7 to both sides, here we get negative 7 plus 7, which is 0. M plus 0 is just m, and that's going to give us 6 plus 7, which is 13. Now let's check it out. We have a negative 7 plus 13. Does that equal 6? Yes, it does. Negative 7 plus a positive 13 does equal 6. 6 equals 6, and we are happy. All right, let's try one more like that. All right, so now we have a negative 13 plus our m, and that equals 2. Again, we add the opposite of this number, so we're going to add 13 to both sides, because again, our goal is to try and get this m alone. How do we get rid of a negative 13? We add 13 to it, and we get 0. We get, oopsies, m equals, what's 2 plus 13? Well, that's 15. Now let's check it out. Does negative 13 plus 15 equal a positive 2? And yes, it does. So that's good. We are happy. That does check out. All right, number 5. This time, instead of doing addition, we're using subtraction. So we're now starting the subtraction portion. And that, what I mean by that is our original equation is subtraction, whereas our original equation here was addition. Our original equation here was also addition. Our original equation here was addition, and our first one, original equation, was addition. So now we're going to begin with subtraction. We have x minus 7 equals 10. And you might be thinking, I know exactly what this is. What minus 7 is going to equal 10? You might be thinking x equals 17. I'm going to encourage you not to do that because our equations are going to get more and more difficult. You do need to know this process. So what do we want to do? We want to get this x alone. We want to add 7 to both sides. Why would we add 7 to both sides? Well, because this gives me 0. So what do we have left over here? Just our x, which is what we want. And over here we have 10 plus 7, and that equals 17. Now, of course, we want to check our answer. Does 17 minus 7 equal 10? And yeah, it does. 10 equals 10. So we are happy. All right, so let's try another. So this one here, we have 15 on this side. It equals x minus 20. Well, again, we want to get this x alone, and it's okay that it's on this side of the equal sign. How do we get it alone? We add 20 to both sides. Add 20 to this side. Whatever we do to this side, we have to do to this side, or whatever we do to this side, we have to do to this side. So 15 plus 20 is going to give us 35. That gets us x equals 35. Now, some of you might be confused because the x isn't over here, but it's okay. It's totally fine. So let's check this out. Does 15 equal 35 minus 20? And yes, it does. 15 equals 15. We are happy. So now, all right, so just like in our notable, I'd like you to copy these 4 down, A, B, C, and D, and try them out. So pause me here, try out these. You're solving for x, y, x again, and m. See if you get them right. All right, so I've copied down the answers. First one, you should get x equals 8. Second one, you should get y equals 21. Third one, you should get 19. And the last, fourth one, D, you should get m. I don't know why I wrote x. M equals 4. And notice here I gave you little notes about what you were supposed to subtract or add to each side. Alright, so just quickly at the very end of the video, we're going to go over what to do to some special cases, like what you'll see on tonight's worksheet. First thing you'll see is something like this, m minus a negative 3 equals 20. Well, we know what to do when we see integers subtracting. We want to take a different color and we want to turn into addition signs. So this now makes this m plus 3 equals 20. Well, how do we solve addition equations? We subtract from both sides, because remember we're trying to isolate that variable, and we get m this is 0, equals positive 17, because 20 minus 3 is 17. Next one you'll see is something like this, number 8. This is example number 8. Q plus negative 6 equals 16. Well, this is still a negative 6. Even though there's an addition sign here, you might get thrown off. You could also rewrite this as negative 6 plus Q equals 16. And we did one just like this, where we add 6 to both sides. We add 6 to both sides. This is 0. This is Q equals 16. Well, that's going to give us 20. Oh, it's not going to give us 24. It's going to give us 22. So Q equals 22. So two kind of different sorts of problems you'll see are the ones with the two negatives here and then adding a negative number. All right, so now go ahead and have a you try moment. I want you to try E, F, and G, and they're just like these special cases that we looked at over here. We're going to need to change some signs or do something a little bit different. So pause and see if you get them right. All right, so for E, you should have gotten Z equals 19. F, you should have gotten M equals 16. And G, you should have gotten X equals 14. If you didn't get these right, go back, rewind, and watch this video here, this portion of it. It should explain it to you. If that still doesn't work, go ahead and ask one of us to help and start your assignment.